Let me open up the chat. All
Hello,
right.
hello.
Hello, we back. We're
Are we
back
here? Are we
again.
here?
Are we here?
Good morning, boys. Hope it's a wonderful stream for you. I appreciate it. Jeremy Santibanez. Yeah, we're locking in, man.
Hey, good morning, Jeremy.
We're locking in. We're locking in.
Let me see. Let me pull it up real fast. Give me a sec. Give me a sec. All good though. All good. I'm here. I'm here.
You're here?
I'm here.
Nice.
There you go. I'm back. Yes, sir.
Yo, yesterday
Hey.
I finally updated my my phone. It
Okay.
was on like iOS 16, I think.
Damn.
So now I'm on iOS 18.
Is that the new update with the little feature of the calculator? Like where you write and
I think that's hold
is
up.
it? I think it's on iPhone too.
I think that's
I haven't updated
iPad.
mine. iPad only?
Yeah, I feel like that was
Okay.
an iPad thing, but I could
Let
be
me
wrong. Oh,
see.
math notes. Oh,
Math notes
okay,
on.
okay.
Oh.
Wait a minute. Math notes. No, I don't know. Oh, Jeremy's already starting.
Let me see. Let me see. Take dictations. Oh my god, bro. Damn, dude. Was I had to upgrade the headphones? No, I've had these already for a while, but they weren't working before. But now I restarted my computer this past few weeks, so maybe they're gonna work because the Bluetooth on my computer was acting weird. So stopped using it because of that. But now supposedly it's working better, so I'm gonna try them out and see how they work.
You want to know
But
something
now I'm
funny
back.
about Jose?
Uh-huh. Oh, yeah.
I always see him in class and stuff, and he's wearing like something new, or he's smelling new, like he has some new like cologne on or whatever. And I'm like, oh, Jose, like you got some new shoes. Nah, man, I always had these. I just never worn them. And it's every single time you ask him about something new, he always says he's always had them, and he just hasn't worn them. Just like what he did right here. He said, "Oh, you had new headphones or whatever." No, I always had them. I just didn't use them or whatever. Like, so
Nah, yeah, I have to be honest. I have to be honest,
like he comes in with new shoes that you've never seen, like in the past year, and I'm like, "Oh, those are new shoes." He bought them, but he says, "Oh, I've had them for years already. I just don't wear them." And he has other items that he doesn't wear either. So it's kind of
Yep.
very interesting. But all right, anyways, you want to get started, man? Let's get started,
I'm
bro.
ready to get started.
We're
Ready to get
6 minutes in.
started
We need to
here.
start writing some code. So,
Alrighty.
all right, everyone. If y'all are new or if y'all are not new, we're still doing the LeetCode Blind 75. So we're on trees right now. As you can see, we completed all these other ones: the array, two-pointer, sliding window, stack, binary search, trees, linked list. No, not trees, linked list. So now we're on trees.
We're in trees.
We
We're in
done
trees.
we did the first three already. Now we're gonna
Yep.
try to do three more today, if not two, if not one. So we'll see. We'll see what happens. But Jose, any other things you want to say, man?
I'm good. I'm good. I'm ready to go. Ready to start coding. Yeah, I'm excited. I'm excited.
It's
I'm
good.
excited to get this. Yeah. Let me do.
Let me get the other ones. All right.
Yep.
Whenever you're ready, man. You can read.
I will read. I'll read this time.
All right.
We got problem 572, subtree of another tree. This is an easy problem, and it says the following. Given the roots of two binary trees, root and subroot, return true if there is a subtree of root with the same structure, node values of subroot, and false otherwise. A subtree of a binary tree is a tree that consists of a node in tree and all of this node's descendants, and the tree could also be considered as a subtree of itself. Okay. That makes a little bit of sense. So we're just trying to find the subtree, a tree under a tree.
A subroot or subtree?
Subtree, yes, 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 yes. So, how do
What are
we
the
go?
examples?
Yeah. So we got example 1. We got root 3, 4, 5, 1, 2, and we have a subroot 4, 1, 2. This is true because the subroot 4, 1, 2 it's a subtree of 4, 1, 2 on the roots, given the root. And then the other one, it is false because even though we have 4, 1, 2 on the root, it doesn't fit the structure of the subroot. Yeah, because over here we have an extra 0. 2 has an extra child when subroot does not. Okay.
So you're given a subroot, and you gotta check to see if that subroot is in the root.
Yeah, yeah.
Okay. Is there any edge cases that we should know of?
I'd say when there's a single root, like a single subroot, right? Like just a node by itself. But I think that is covered already with the fact that we have to check if they're equal in structure. Or if root is empty or subroot is empty, we have to check those. If one of them is empty, that'll be false, right?
Okay.
Yeah, I think that'd be pretty much it.
Oh, okay. So it seems like there would always be one node in there.
Oh, okay. Both of them? Okay, okay, that makes sense. So we just have to check if I think so, no?
Yeah, it says it right there.
Oh,
so,
wow, oh, wow, oh, wow.
Based on some tree algorithms that we
Traversals,
know
yeah.
of.
Which one would fit the best?
Are we immediately thinking traversals, right?
Yeah, I'm gonna do I think we should do traversals.
Traversal.
Yeah. Traversal. And then but how would we do it though?
Because if you do my question is, let's say we're looking for we pre-order each tree, right? Like pre-order traversal.
Yeah.
And whenever we get a 1 here, we check it with this one 1, and then we go to the next pre-order spot, and we go to the next pre-order spot, and then we go to the next pre-order spot, the next one, and then if this one has another one, like this one right here, if it goes to a different one, then we know there's nothing left here. So that's false.
Yeah.
That's just an idea.
Last week we had a similar problem like this, but instead of finding a subroot, we compared 2 trees.
Yeah.
Where we had to do the what was it, pre-order thing, and we sent the So
I mean, I think you could do whichever traversal.
Yeah, for sure.
But like pre-order, I don't know. I just gravitated towards that, I guess.
Hey, no worries. I'm done for that.
That's just an idea. That's an idea.
Yep. I get you.
Cause then I was thinking, like, how do you know if, like, if you go down 1, 4, 2 and you go to 0, how do you know when to stop? Like
when the other one rents out. Because what I was thinking, right, is like whenever we hit like the head, which is 4, so we hit 4, 4. Here we start checking both the subtree. So we go 4, 4, right? Since it's pre-order, we go to 1, and then we go to 2, right? And since 2 is gonna stop, the pre-order traverse is gonna stop for subroot, and root still continues since it has a child, right? This is false because
Yep.
this one, the root still wants to continue.
Yeah.
Yeah.
That's exactly what I
So,
was thinking.
hmm
Because
so
I
I
was
was
thinking like
thinking,
without doing that, how else would you know when to stop on the left side?
yeah, exactly.
You need to always check this
hmm
right here.
hmm
But okay.
And I
So
was
what you
thinking we can use like the same logic as the previous problem into here, but we just have to call the function. Um, yeah, yes. We could have a function that runs like the 2 subtrees, right? And then we have another traversal that goes through the root, if that makes sense.
yes.
So we're gonna
Yeah.
have two traversals going
Two
on at the same
traversals.
time,
Mm-hmm.
and then one that goes through the root, and another one that compares the subroot and the subroot of root.
Oh, it's gonna be the one where you could import two roots, correct?
Yes, that's gonna be one function.
Wait a minute.
Wait a minute.
So you're saying we're gonna have two function calls
Mm-hmm.
with two parameters each.
No, two function calls, one with one parameter since we're starting at the root, right? And another one, whenever we traverse a root and we hit the value, the same value as the head of the subroot, we trigger the other function that's gonna check both trees same time.
So it's a nested function.
No, two separate functions. Two separate functions.
But how are you gonna trigger? Oh, okay. The first one,
Yeah, you're gonna
it just
call. Uh
goes
huh.
until you get the root of the
Yes.
subroot, and then
Yeah. Until you.
it's gonna end that call, and then go
Uh huh.
into now the roots match. So
Yes.
you could call the next function with both the roots in.
Yeah. Uh huh. Yeah.
Okay.
Yeah. And then we check that, and then we return false. We continue to the other function where it's gonna check 1 and 2 to see if there's a potential subroot over there at the end.
Now I have a question for you.
Uh huh.
Could you do that with just one function? Because couldn't you just use a while loop inside that beginning function? Oh
Oh, we
no, it's
can.
recursive. Isn't it recursive?
Yeah, it's recursive.
But I guess there could be a base case that activates that while loop, and then it just loops until it hits the base. I mean, it hits the subroot first root, and it continues. But that base case will need to be set so that while loop
Mm-hmm.
doesn't reiterate. Just an idea.
Okay. Okay. Hmm. Because I was thinking the same thing, but it'd be a little bit difficult having one function. It'd be a little bit more complex. Not difficult, just a little bit more complex.
Okay.
Hmm.
We could just
Not
do what the first idea.
Yeah, and then we can
Yeah.
enhance it
Yeah.
if you want. Yep.
So do you want to copy the code from the last problem or just let's
Oh,
redo
no.
it?
Redo it.
Redo it.
Redo it.
Okay.
Come on, man. Redo it. Yes,
I was
sir.
just making sure you're on the right path, man.
Yeah.
You know.
All good, brother. All good. All good.
All right.
Hello,
So,
Ali. Welcome to the stream, Ali.
Allie, what's up?
Thank you
What's
for
up?
tuning in. All right.
What should we call this?
Two tree traversal.
Two tree.
Two tree. Yeah, we can call it two tree. Yes. And we're
Root.
gonna have root 1 and root 2.
Yep.
Yeah. Okay. So here, if I don't, let's see.
So this one is supposed to. Okay, now I'm curious.
Yeah.
Since we're gonna have this.
Yeah.
And we're gonna have this. Right.
Yeah, but the second one only works on the root, one root.
This one.
Yeah, only works in one root. Whichever. I would say the second one. Because one of them is going to traverse to the root. It's going to go to 3, 4, 1,
Yeah,
2,
wouldn't that be the
5.
first one?
Mm,
Because you want to get the basis first. Do you want to find out where to
yeah, I
start?
mean, yeah, we can do that.
So we're gonna pass in root 2, but not use it.
No, we're going to pass in root, just root.
Yeah, but so then why do we have 2 parameters?
Oh, that's so true. Well, we don't need 2 parameters. We just need 1.
Okay, but we still gotta pass it though, because we're using the
Do
same
we?
function right here. Because we're using the
That
same
is true.
function.
That is true. That is true. Mm. Let's see. Let's see.
I say we could do that while loop in the beginning.
Let's do the while loop. Let's see. Let's
Okay.
see. I'm interested.
So the base case will be similar to this, while root. Do we gotta do dot val? Root dot val
Yeah. Yeah.
not equal sub or root 2 dot val root. Oh, okay, now we gotta do the we gotta traverse through it.
We gotta traverse through it. Yeah, because while we can do like a queue where we can add the left and right child into the queue, then pop the queue, and loop that way, right? And whenever we hit the same node, right, we exit out of the loop. That's an interesting one.
Or we just create 2 functions.
Or we could create 2 functions too.
Let's see. Or, hear me out. Wait. Wow. I was gonna say, I was gonna do it right here in this function, and then you create. I don't like this.
You don't like this?
Because I don't want to create 2 functions. But
Yeah.
maybe we have to.
I mean, I said 2 functions because that's the way I envision it. But we can always find another way.
Okay, how about this? First,
Yeah.
let's traverse the root until it equals subroot.
Let's do that. Let's do that.
Get root to equal subroot head or root. Okay, so that would be that.
Yes. And now, yeah.
And then the logic is right here.
Yes.
Oh. Yay or nay?
Yay. Yeah. So now if they're equal to each other, what do we want to do if they're equal to each other?
Do we want to return a node?
Okay. I think we can return it just for now. We can return a node and see if it works.
You want to print the node or?
Yeah, we can print the node. Yeah.
And then stop. How do we tell it to stop? Then return?
Yeah. Wait a minute. Wait a minute. That'll
Wait a
give
minute.
you.
Wait a minute. Wait a minute.
Fast.
Wait. If root is none.
Yeah. Mhm.
I'm running it.
Oh, I thought you were gonna submit it, bro. Damn.
Subroot.
Oh, capital R.
Oh. Of course.
Oh, because you
Oh,
had
it takes
to
two.
submit the other one. Yeah.
Wait a minute.
Root 2 dot left, root 2 dot right.
Wait, no. We just need to keep that root value.
Well, yeah, that is true. We can do that. Root 2. There you got a 4. Got a 4.
Yep, okay.
I'm
So it
thinking
seems
about
like
this because we can say, all right, we can traverse, and as soon as we hit that 4, right, we can
then we
call.
do it again in here.
Yeah, we can call the DFS, the root dot left and root dot right, or root 2 dot right, like call traverse both then, right?
Like this?
Yeah. And then, so here, let's think about it. Let's run it through. Let's run it through. So it's going to start at 3, and it's just going to start at 4. They're not equal to each other, right? Root 2 stays at 4. Then we go to the left, which is 4, right? And then at 4 and 4 are right. They're correct. They go to 1 and 2. They're correct. We go to left and right. Then there's nothing. We go to 4, back to 4. Then we go to 2. Go left and right. Yes. Okay. Mm-hmm. You
But
go
we
to
have to
2.
say, don't we have to say,
Yeah, we have to get the value. Let me see.
because if they don't equal each other at the end, then
Yeah.
that returns a false or something like that.
Mm-hmm. Yeah, we have to return left or right. Wait a minute. No. Because we have to return. Let's see. So we go to 4. That's true. I think we need a variable. No, I don't think so. Because you're right about that. We have to do the left and right. We have to track those. So it's 4. You know where they're gonna fail? No. No, that's not right.
I don't like this right here. I don't like how whenever we call it again, it's gonna go through this right here, which this might not work.
Yeah, it only works for the first time. Now, so we have to take into consideration that sometimes some children are gonna have some other children, and we have to check if those are if there's a mismatch between, for example, in example number 2, right? 2 has children of 0, right? But the other 2 doesn't. So we have to check if 2 of them are none.
Well, I say we just return the node, and then this would be like node equals, right? And then
Mm-hmm.
you run it again. DFS, you're taking both of them in, and then
Okay, and you traverse from starting from there,
yeah.
starting from 4 instead of 3.
Yeah.
Okay. I was trying to do the same thing with the 2 double functions.
Yeah, no, that's what I'm doing.
Yeah, yeah. I'm down for that. Let's see. Yeah, because doing it in one function, I'm pretty sure you can, but it has to do with not sure. But let's see. So we got the node, right?
Is this how you do it? Can we double check that?
Mm-hmm. Mm-hmm. Hmm.
Because whenever it returns to the previous call, and then that call is not returning anything over here.
Yeah,
Or should these be variables?
I think so. Yeah.
Let's say this one holds root value.
Return the one that's equal to root 2 dot val. So it's gonna
Let's do an else or nah. Or two.
if you want, yeah. And yeah. Okay.
Okay.
We had it right now, no?
What do you mean?
Like we were printing the value, or was
Yeah,
we were
because that was
turning?
right here. We're printing the value right here.
Okay, I see, I see, I see, I see. Mm, damn. Too early, it's too early. Oh, come on. Time to lock in, time to lock in. Okay, print that value. But if you return it to over here, to back, back to positions, you check which one is which. You return val1, val2. I tried deleting all the print statements. Let's see, except that one, except those. These are where the ones where we try to also line 36. And try running it, maybe? Mm-hmm. Check in the if statements, if bar 1, try doing the val, var 1 dot val, root 2 dot val. Check the values,
Yes,
maybe?
yes, that's totally right. Because they're not the same node. They're
Yeah,
they're looking for the same value.
maybe.
Chihuahuas, man. Oh,
Never mind. Um,
no, no, you're onto something. You're onto something. I think that was correct though, because they're not the same node. Or is it?
yeah.
It's a subroot. No, they're two different trees.
Mm-hmm.
Okay, yeah. Or is it? What if the problem just got this and then removed it out? Or is it bringing a new tree? So that
I
means the
think it's a new
nodes won't be the.
tree. I think it's a new tree.
Okay.
Mm,
So,
come on, man. Oh, come on, come on. We got this, we got this.
okay, so let's trace it. Let's trace it. So, if root's none, that's not none. If root.val equals root2.val, that doesn't. So then var1 dfs root.left, boom. Root still gets passed through here, yep. And then you go from the top, no, they're not none. Root.val equals root2.val, that is correct. You
Mm-hmm.
return root. So this should have value, should have root.
Yeah.
Then this one goes. So root dot. No, you return this. So you
You go
start
to
here.
5. Yeah, you go to 5. And 5 starts from the top.
Yes. 5. Root. No, it doesn't equal. So you don't return anything. And then
Well, here,
it does the left. There's
var,
nothing in the left. Huh?
yeah. So what's happening? var1 and var2 are equaling to no, because since they have nothing, var1, var2 are equal to no. So we have to check if those values are no too. Because when you call 5, right? 5 has no as a left, no as a right. So var1 is going to equal no, var2 is going to equal no. So we have to check both and be like, all right, so if none of them are, first we have to check if var1 is null,
Then you
right? And
return.
var2 is null. Yeah, the if statements. Check if var1, if var1 is none and is not none. Is not none. No, just one time, just one time. The first none. Yeah, it's not. There you go. And delete the var1 exclamation point none. There you go. And we just have to check. Aha. So if var1 is none, right, it's gonna be like, all right, it's none. So it's gonna jump out, right? Since if we check var1, and it prevents it from checking var1 dot val. So it's like a security precaution to not get there. Because right there on var.1, we're gonna check if the value.
But my question is that we're over here, right?
Mm-hmm.
We're over here. We returned, so we're at 3.
Mm-hmm. Mm-hmm.
We go to the right. We're on here now. We go to
Mm-hmm.
the right, and then so then we start back here,
Mm-hmm.
and then we go. If is it root? Nope, it's not. So then you do left. There's nothing in the left.
Mm-hmm.
So you don't do that. There's nothing in the right. You don't do that.
Mm-hmm.
Then it's gonna say if
All
var
of
one
that.
is not none,
Yeah.
which var one is
Is none.
none,
So it's not gonna execute
not
that.
gonna do it.
Yeah.
But
Same thing for
we're
var2.
but we're never gonna go back to where we were at 4.
Well, we're gonna return at the end,
Oh,
return none, right? So if both var1 and var2 are none, right? That means it has no children, so it's gonna return none to 3, right? So now it's var1, right? That's holding the 4, and then var2 that's holding none. We're gonna check the
so return
values.
none.
I think so. I believe the return none is
But then
gonna do the trick.
now we return none over here.
Yeah, which is var2 for 3. Yeah, now var1 is gonna equal to 4, right? And then var2 is gonna equal to none. So we're gonna go to the first statement. Is var1 not none? Yes, because var1 is 4, right? So it's not none. And then is var1 that value equal to dot value? And if so, return that node, right?
Okay.
And it's gonna quit.
All right. Let's see.
Wait, we
Uh,
forgot the bar that val.
uh, uh, this one.
Yeah. It's just a guess. It's a blind. It's
No,
a
I think
short.
it's a great guess.
I'm not sure. Okay,
There you
so
go.
hit high. Now print node over here at the after. Yeah. All right. Let's see. Okay. Okay.
Good stuff.
Okay. Oh man, it took some serious thinking in here. Oofas. Ah, my brain power. I'm sleepy, my boy. Hey, but we got it. We got it. We got it. We got
Okay.
it.
That was
Right
first
now,
step.
that's the first step.
First
Right
step. Yeah.
now, what do we want to do with node? With this node?
We wanted to traverse both times. We wanted to traverse at the same time, checking each node. And then
Yeah.
once it mix matches, then you return false. Or
Yes.
if there's nothing left on the subtree,
Yeah.
then you have to cancel that.
Mm-hmm. Yep. And
But we
also,
might need to do a different function though.
yes, for that, yes.
Also, what?
Oh, what if there's different nodes with the same number?
The binary tree.
Okay, okay.
Different nodes with the
So we
same
don't have
number. What do you mean?
like duplicate numbers. Hopefully there's not duplicates.
Can there be duplicates? It's a
Uh,
binary tree,
uh,
right?
let me see. Binary tree. I mean, I don't think it's a binary tree because
It says it right
it's
here.
not. Oh, let me see. Can have duplicates depends on the application that uses the tree. Some binary searches tree allow duplicate keys while others do not. Uh,
You got to be kidding me.
let's try solving this one. Let's try solving these two, and then we'll see what the other test cases.
Okay.
Because I do believe I'm not sure. It was just like a little edge case I was thinking about. But let's do this first. So first of all, okay. Do you remember how to do it?
Nope, but I'm going with the flow.
All right.
Something like that. Something return.
Wouldn't it be true?
Because this
Oh,
means
wait a
there's
minute.
nothing.
Yeah.
Keep trying it.
Okay.
Keep trying it.
Yeah. 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 Let's just sketch it out. Sketch it out. Mm-hmm. Yeah. So you have to have the same number. Okay. Now the only thing we're missing is to check if the children we have the same children. Yeah or nay? Yo yo yo.
So it's going to be 4.
Mm-hmm.
4.
Mm-hmm.
That's true.
Yeah.
It's going to return true, but that's going to immediately start at the beginning. So this might not even work. So because
Mm-hmm.
it's going to return true, and then that's it. We're going to stop because there was no other call.
Yeah. Yeah.
So I guess you just, if they equal each other, if they don't equal each other, return false.
Yes.
Okay, got that. Then we
And
go
then we
left.
have
Boom, boom. And then we check, is it none? No, they're not none.
okay.
And
So for the
then
ifs,
this one we now need to improve. But what?
no, I was gonna talk about that if statement because
Because
we have to check
or,
if they're
like, isn't there an or something like that?
yeah. Because what if they don't have children? Like one has and the other one doesn't. So for that, turn true. So we got 4, 4. We check if they're none. We check if they have children left and right. What are you thinking right now? What's your thought process?
Well, I kind of wanted just to keep going and then see if.
Okay, yeah, let's go.
So if
I'm down.
root dot left and root 2 dot left, they're not different. So then you keep going. Then you're over here. Wait, no. They're not different, so you keep going.
Mm-hmm.
Root dot right. Wait.
So
I'm
you
confused
go
right
to
now.
2. Yeah?
So root dot left, we're here.
Mm-hmm.
So we're right here. Okay?
Uh-huh.
Oh, okay, I see. And then you say wait, no. Wait, yes. It's depth first search. Wait. Yes. Okay.
Mm-hmm.
So basically what I'm getting is like why doesn't it go down here? And that's because this right here, if it's none or whatever, then go back, it returns back up, so then root dot right is there. Root dot right is this too. Orcus, what's up, man? How you doing, Orcus? You doing good, man? That's good, man.
Hey, Orcas, welcome to the stream.
Root dot right, root 2 dot right.
Come on. Let's see. Think about this one. What are you having trouble with?
No, I was just tracing it in my head and kind of got sidetracked. But
So it's gonna cover the none. Then go left.
we're doing good. We're doing good.
We're
Tired.
doing good, Orcas. Yeah, we're doing some early morning LeetCode. So surviving here. We're surviving here. So this works. Kyra, welcome to the stream.
Yo, what's up?
So this one works, right? But we have to return true at the end after left and right. So
It's
Jeremy.
like so easy in our head, man. You're like, oh, you know, 4. Oh, check that one with the other one. Oh, 1, check that one with the other one. Oh, 2, check it with the other one. Boom, you're done. But no, it's not like
Okay,
that.
what's the hard part from this thing? What are you
Yeah,
having
I know.
what are you having
That's what I'm
trouble
trying
with?
to figure out is I'm
Oh,
confused on how do we say it's false whenever there's a child node on the root side.
oh, well, we check the left and right. So root dot left, if there's a root dot left and a root, if the root dot left equals no, and root dot two dot left equals true, right?
So what you're
It's not none.
so what you're saying is that this one right here, if this is the last ever if statement that is ran
Yeah.
in a
Mm-hmm.
call,
Mm-hmm.
like let's say we got to this right here.
Mm-hmm.
So it's the last ever if statement call because there's nothing more.
Mm-hmm.
If this returns false, this false is gonna override all the way to the beginning.
Mm-hmm.
Okay, I'm
Mm-hmm.
good now. I'm good.
Yeah, but that's
So
the thing.
let's.
Wouldn't it be true? Because if both, because here we're checking. Let's say we go to 2, right?
Okay.
And then we go to the left, right? They're the same structure if they go to the left. Well, let's remove 0 from the equation, right? And we go to the left, right? That should return true, don't you think? Because they don't have nothing on the left. And if you go to the right, they have nothing on the right. So that's true.
Yes.
So this 2 and 2 share the same structure, right? And now we're gonna have to check if root dot left, right? Let's see. If root none,
Like same. I'm trying to find a way to say like, if one of them's none and the other one's not none, then return false.
return. Also, for that, you have to check the children from both. So root dot left is none, while root dot 2 dot left equals. Let's see.
Well, I don't think we need to check the children because the recursive call is gonna
Yeah,
be
it's already
there.
checked. Yep. Uh-huh.
So we
So we
just
just
gotta
have to check
say it. I
if
mean, we could
root
write it explicitly saying if root
if root
is
is
none
none,
and root 2 is not
root 2
none, or root
exactly.
is not none and root 2 is none.
Yeah.
But I was wondering if there's just a way you could say it like in
Yeah,
like
in a
this,
simple statement, yeah.
but there isn't or no.
Uh, it's none. Already checked that one over there. Yeah, I think you can do so. Yeah, you can do and or this one because if they're both not the same, right? If they're both empty, we already captured that one. But if one of them is empty and the other one isn't, we have to return false. So you can do it with one statement. Root is none and trust 2 is or trust root 2 is none too. You can do it with that, and then you return false.
So the first way I had it.
Yeah. Because the first if statement is gonna check if both roots are empty, right? For example, let's remove 0, right? 2 and 2, you go to the left. If we remove 0, those are empty, so it's gonna return true, right? But if we put in 0 back into the equation, the root is 0, it's not gonna equal none, right? So that's gonna jump out, right, from the first if statement. Well, it's gonna jump in,
Pause.
and root 2 is none, so it's gonna
I think
jump out.
pause real quick.
Yeah. Talking too much?
No, not that. I just want to
Okay.
clarify something. Also, Orcus
Yeah.
said, "How is life at college? Having fun?" Uh,
Ooh,
yeah. I
here and
mean,
there, here and there.
I enjoy hanging out with my friends. Yeah, but like
Damn, we're
having
not that
fun,
fun.
I don't know what you mean by having fun. Like
Damn,
you mean
bro.
like
Guess your friends are
DJ
not
like
fun,
party or
bro.
something. If you're meaning like DJ party, then no, that's not the type of fun we're having. But we're having other types of fun. Yeah, like coding. Okay. Anyway, sorry. We're just to clarify. You were saying that since these two,
Yeah, because they
since
share the same
since
structure.
since this is gonna return false, let's say, that means we could guarantee that both of these are not none, but they are
Yeah.
none. So you can't guarantee that one is
Well,
none
one of
and one
them
is not none.
isn't. One of them isn't. Because in the if statement, both have to be none.
Oh, okay. Okay.
Yeah, and then the second one isn't none. So if one isn't none, that means that one of the nodes has an extra child, so we return false.
Okay.
And then if they both have the same structure, we check the values, right? And then returns true. If you want to run it again, I'm down to run it to like yeah, and you return left and right. Yes, 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 yes. Not sure if it works. Oh my god. It worked? It
For
worked.
these two, yeah.
Oh,
All right.
damn.
Well, let's see. Where are we at? Come on. Uh.
Oh, fast.
Oh, we're cooked. Only binary trees can exist. Oh, we're done. We're cooked.
We're cooked?
Are we?
I don't think so. I do not think we're cooked. I think we just need to tweak it a little bit, right? Because what's happening here is that we have two nodes with ones, but we're getting the first node. So here, what if every time we encounter the same number, right, we call DFS2 and check if that has the same structure. Like for the, let's call, we have 1 and 1, right? Let's call it for the first one to see if it has the same structure, and let's call it for the second one, for second one, for that structure.
Okay. Where would you do that
And
at?
we can do it on the first function on DFS, inside DFS,
Okay.
where once we find the same where is it on the root, right, root here 92020, we just call DFS2 with the root and subroot, or root 2, yeah, this is yes. And then that's going to give us a value, either false or true, right? No, would we return it?
I don't know. I'm following what you're saying.
We have to save it in a variable, I think. Yeah, save it in a variable, and that variable is going to change. Damn, bro, I'm not sure. Do you think it's going to work?
Bro, this problem lost me. Because
Oh,
here's why.
uh-huh.
Here's why.
Yeah, let's see.
I think we could definitely solve this.
Uh-huh.
But for some reason, we're like thinking it like way too much.
Okay.
Like we got ourselves like in quicksand. Like if we're in
Okay.
quicksand and then we kept moving really fast and we kept going and then now we realize how much deeper we're in the quicksand. And that's where we're at right now.
Okay.
Is
Okay.
I'm not saying we panicked, but we overthought it a lot. And now look at us.
Okay.
We're here. And now it's even harder to, for me at least, to think of the solution because we fell so far back from the original idea.
What was the original idea though?
Well, I'm just saying like the simplicity aspect of the original idea, which was you check, you get at the same root, and you check each one after that.
Yeah, I mean we did it, right? But what if they have different nodes have the same number? Because we did get the simplicity. We did manage to get that, but the problem is just a little bit more difficult. You get me? Because we did get the simplicity, right? We did you said, we checked the node, we got the node and checked it, but then we forgot to think about the edge case where there's different nodes with the same number. Yeah or nay?
What? Why is this an easy? Like,
I think it's an easy, because if you do the problem where you check the trees and combine it with a little bit of traversal, you know, you just have to figure out when to check both trees, and it's a little bit of recursion. So I think it's a hard, medium, easy. Like it's a pushing to the medium.
are you doing the timestamps?
Yeah, I'm doing the timestamps. Doing timestamps.
Oh
Yeah.
man.
You gotta do a little bit of a breather, check our
Yeah,
insanity
bro.
level.
We
Okay.
need a breather, man. I'm hurting right now. All right, let's see. All right, Jose, you go first, man. Actually, I'll go first.
Uh, yeah, yeah,
I'm
yeah.
at a I'm at like a 7 for sure.
7.
Yeah,
I'm up there with you. I'm like at a 6 too. I don't. My head hurts because I'm tired. Barely woke up. Woke up to this thing. Saw it. I thought it was easy. Now that I look at it,
but I'm not ending the stream until we solve this.
oh
Until we solve
damn.
it the
Okay.
right way. There has to be a right way to do it. What are we missing? Why are we doing two
I'm,
functions? I understand the simple human idea. It's so easy, but why? What's wrong? Like what are we overlooking? We have the tools. We've done a lot of different problems. How are we
uh-huh.
overlooking this? Can we look at a hint?
Go for it.
Whoa! Thank you
Iterative.
for the hint. Next one.
Next one. Next one. Next one. Huh. Is identical. I mean, that's something we had over here at DFS2.
So, do you mind if we switch to Skeledraw? Can you show me how this 1 1 1 is messing
Yeah.
up?
Yeah.
Okay, I'm here.
Okay, I'm here. Yeah, right here, right here. So basically, this 1 1. right? We got it one here.
Mm-hmm.
We got another one here. And we have another subtree right here. So this is our tree, these are subtree. We where the function is doing is grabbing the first node that is equal to 1, right? So since the first node 1, since this node right here is a first node that equals to the or sub, right?
Mm-hmm.
Or the head of the sub, we're gonna get these nodes and we're gonna compare them if they're identical. So we're gonna do 1 and 1, check, the heads are identical, but
And
this
it
one has
goes
an
into
extra.
this one.
So that's a false, right? That's where our algorithm, it is working when it comes to this. But to answer the question, right? What if, right? This is 1 and 1, right? We check that this tree right here is false, right? This thing is false. But what
But
about this
this and
subtree over
this
here? Exactly. These and
are
this are
false.
the same. Exactly. So what my approach was to iterate through each of the nodes, and wherever we hit a node that's equal, we check that subtree, right? So we check 1 and 1, okay, that's false, save it in a variable, var, right? And then we go to the next one. All right, this one is also 1, so let's check these two and see if that's true.
Okay.
Because what are we? Yeah,
Yeah.
that's the problem right here. Because we're grabbing the first one, right? And it's like, all right, is as the first one, that's the only tree that existed. But what if there's another one over here down the road?
Okay. I see that then.
Yeah.
So I
So
think I
our
think you found the right spot. And then I think you
yeah
say like if true, then return it.
yeah yeah we can do that. Yeah, if it's true, yes, we can return true. Yeah, actually, yes.
But do we have it synced up correctly for it to? Oh, yeah, seems like it.
Seems like it. Yes, seems like it. And to
So
be honest, I don't think we don't. I don't think we even need to do the var 1, var 2, because those vars 2 we're trying to get the node, but we already have the node, so we can delete. I think we can delete
I
those
don't think we have
lines.
the node.
We do on over here, because as soon as root dot val equals to root dot val, that those are the two nodes, and it's a recursive function. So you're gonna call DFS root 2 comma subroot, and it's gonna do it by itself. Because we had the var 1 and var 2 to determine the nodes, so we can exit out, get the node at the end. But since we already have the node,
Okay.
Yerine, Yerine,
Mm,
come on, I'm not gonna let you down. I'm not gonna let you down. I want you with me. I want you with
I'm
me.
a little bit confused on that again. Could you explain
Okay.
that? You
Yeah.
said we don't
So
need var 1 and var
yeah,
2
I don't think
because
so, because those var 1 and var 2, um, we needed those to determine the node, right? Because we wanted the node to call the other function outside this function. So we wanted to return the node. So that's what we were checking. Like, all right, so VR1, VR2, right?
oh,
Which
okay.
you get
Okay.
me? Like which
Yes.
one is which to return this or return that. But we already have the node on the if statement. So whatever root it's equal to the other root, those are the two nodes that we have to call into DFS too.
But then
And it's gonna go.
how does this go all the way to the front though if we have a return none at the bottom? That's
Um.
why that's why
Oh, okay. I
these
see.
stop it from getting to here.
I see. I see. I get you. I get you. Hmm. Well, we can do an if statement. If var1 and we can return
Hey, this means it's
let's
going
see.
crazy right now. Hold up.
I'm hearing it through the Discord and it's pretty good. Let me pump it up. All right, so we got the var, so that's gonna return true. But if you go to the right,
Or should we just return var?
I think we can just return var. Let's try it out.
Where did I put that? Where's it at? Mode, name, node. Okay.
Oh,
What is it called?
oh, because we're returning var right in the if statement. Oh man! All right, we're close. We're close.
No, it's because there's no var in this scope right here. There's a var in
Mm,
this scope,
yeah,
but
yeah.
so
I mean, you don't have to return anything.
you don't.
I don't think so. Or you can return. You can save the values of DFS and DFS and do return DFS and DFS to, yeah. Oh, bro, my head is already hurting, bro. I don't like this.
Wouldn't
Like I
one of
said,
them be false? Or like there's a
what do you
chance
mean?
it could be false. So you're saying return var 1 and var 2?
Yeah. Yeah or nay?
That's why I'm saying we need to have this.
Well, that is true.
But maybe not this right here. Wait. Yeah, maybe. Yeah. Yeah, maybe not this right here. Or maybe something similar like this. We just say if var 1, return var 1. If var 2, return var 2.
Yeah, we can do that. Yeah. Yeah, that would work. That would work. Okay.
Please.
Okay.
All right. Let's keep looking at test cases. Come on.
Bro, I'm scared of those, bro. I'm scared of those. Yes. Okay. Come on, bro. Come on, more. Give me more. Give me more. Give me more. Give me more. Oh, right there. Oh my god. Oh, I don't want to. I don't want this. I don't want this. No. Bro, that's scary, bro. No, they're crazy.
1, 2, 3, 4, 5, 6.
Ah, bro, my heart is like boom, 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 boom.
Oh, wait. Wait a minute. Okay, let's do these.
The last one right there. Yeah. Right
So they
there.
just
Oh,
want to
invalid
mess
test
with
case.
us.
Think so.
Huh?
It's invalid. Oh, because you have to click enter. It's still in the same line. You know how 5,
Oh,
5,
okay.
9, 5. Yeah.
That's
There
why.
we go.
Okay.
Yeah. Let's go. One more. Bro, bring the big boy. Bring the big boy. Yeah. That one. Number 7. Yes. Oh, mamma mia. Come on. Right there. Right there. Click enter. Okay, it's 6. 5.
Yeah,
Okay.
that's right.
Yeah, that's right. That looks like right. Let's go. Ah. Bro. Ah.
Wait.
Bro.
I need
Don't
to
mess
do
with
one
me.
more test case. One more
Don't
test
mess
case.
with me. Ah. Whew. Let's go.
And it
Let's
says it can't
go.
be empty, right?
It can be empty.
All right.
Ah.
Submit it.
Come on,
We're
brother.
submitting.
Let's go.
Wow.
97%, bro. 97%. We did it. Oh my God.
Why'd you say it like that?
It's what's his name?
Jason Tatum.
Jason Tatum. Yeah, we did it. Oh,
That's
brother.
funny. Oh man, how long was that? An hour
Oh,
and 20
brother.
minutes?
Oh, brother, bro. Oh, brother, I forgot even about timestamp.
Wow. Finally.
We did it. Oh. Oh, man, bro. All right. What? You know, it was a teamwork. It was teamwork. You figured out the logic of when to return what, and I was just, oh, brother.
Still got 1, 2, 3, 4, 5, 6, 7 more. Chatter, we cooked.
We cooked. I think we're cooked. How do you feel now?
I want to see what they said.
What they said? What they solution? Oh, brother.
If not subroot, return true. If not root, return false. Yeah. Hold on, I gotta move it a little bit. I can't show the chat because it doesn't go down even lower.
No, there's a copy button, I think, on the top right. Okay, there we go. Oh,
So
wow,
this
let's
was
see.
the code. So they created a new function.
Yeah. Okay, so they did the DFS2, same tree, right? That's basically, and then if that's up to if same tree, root that subtree, return true. Return sub. Okay, so they use this is subtree to traverse. So yeah, they basically did it like us.
I see. So they didn't create.
Yeah.
They didn't necessarily create another function.
Yeah.
They did the subtree to traverse, and then use the new function to. Okay.
Yeah.
Very
Hey, we weren't
interesting.
that far. And also here,
Wait, how
I
did they
don't think we need
traverse? If not
using the
subtree.
same.
No, how did they traverse? I don't see it.
Right here on line 17, it says root.left and root.right.
Oh, oh, that's crazy.
Yeah. Yeah, that's pretty smart.
Interesting.
Yeah.
What are you gonna
And
say?
can we try I think we don't need the if statements on the last if statements. I think that self they return on
These?
var. Yeah. Because I saw it over the other guy's code, and I think we just have to return once. Oh, never mind. Yeah, never mind. I
Never
take it
mind.
back. I take it back. I take it back. I take it
Never
back.
mind.
I take it back. I take it back.
All right.
Oh man, bro, I don't want to explain this code, bro.
I don't want to explain it either.
Yeah.
How about
Means no run.
yeah? Yeah. Let's see. What are some other solutions people got? Okay, they did the same sort of thing. Traverse with this.
Mm-hmm.
All right. Well, Jose, what do you want, man? What do you want? We got.
Oh, you tell me, brother. You wanna see the other problem and see if we get the gist of it? Cause I don't know how you feeling. I feel like I don't know if you want to continue.
Let's see. Least
Okay.
common ancestor. Ancestor. Lowest, not least. Okay.
Lowest.
I guess I'll read it. We'll see. We'll
Okay.
see if we're feeling it. We'll see if we're feeling it. Given a binary search tree, find the lowest common ancestor LCA node of two given nodes in the BST. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself.
Pause. Rewind. Read it again.
Given a binary search tree, find the lowest common ancestor node of two given nodes in the BST. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself.
We cooked, brother. I don't. Think we're cooked. Ion. So the lowest common ancestor is defined between two nodes P and Q as the lowest node in T. All right, let's see. Let's see the example one. Let me see. Okay. Okay. 2 and 8.
What? What
The
is it
lowest common
saying?
ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q. Go down. Go to example 2. Let's see.
Oh. Okay. Wait a minute. We might be onto something.
Oh, P. Okay, 2 and okay. We're given the
They
ancestors.
give you 2 and 8. Wait, no.
Yeah, they give you 2 and
Oh,
8, and you have to find the parent of 2 and 8. But the lowest parent of 2 and 8.
So they give you 2 and 4. Boom, boom.
Uh-huh.
The answer would be 2. No, 2. Since a node can be a descendant of itself according to the LCA.
Okay. Makes a little bit of sense.
I
Yeah
need
or
more
nay?
examples. I need more examples.
So, to my understanding is that you're given two nodes, 2 and 8, and you want to find the lowest node or the lowest parent that has those 2 and 8. It says
The
there's if I'm
lowest parent.
the lowest parent that has 2 and 8. For example 1, you're given 2 and 8. Which is the lowest parent that has 2 and 8? 6, right?
Okay, but my
And then
question
example,
is,
uh-huh.
why? What? What do they mean by lowest parent? Like,
Like,
what if there was a 5 right here, and then oh no, what if there was a 10 right here, and then an 11 right here? Would that be 11?
no, because those are not parents. For example, let's take 4, the lowest 4, and let's assume it had 2 and 8 as the children. 4 would be the answer, right? Even though 6 has 2 and 8, 4 is the lowest parent.
Wait. Repeat that one. That last one again.
Let, let's say 4 has 2 and 8
Let's say
as
4
children.
has 2 and 8.
Yeah.
Okay.
Since 4 is lower than 6, 4 would be the answer because 4 is lower.
Okay.
I think that's what
Hear
what
me
it's been
out.
asked.
Hear me out.
Uh-huh. Yeah, for sure.
This is a binary search tree.
Yeah,
Is there any duplicates?
I'm pretty sure.
It's a binary search tree.
Whoa, I think so, but I'm
Because
not sure. I'm
remember
not
that
sure.
last discussion we saw where it said it's a binary tree. That doesn't mean that there's not duplicates. But a
Yep.
binary search tree, that's different. This is a binary search tree.
Yeah, I don't think that it has duplicates.
So that's kind of what I'm getting at is what case will we ever have 2 and 8 down here and then we gotta do 6 and 4, we gotta compare, oh this one's the lowest.
Yeah, I
So
get you.
in
I
that
get you.
sense, what I'm saying is wouldn't it just be whenever you find children 2 and 8, you return the parent? But that's what I'm assuming, and I don't think that's correct. I'm trying to find out what does it really
Oh,
mean?
I
Like,
think
cause
so.
I think there's a catch. I think there's a
Yeah,
catch that I'm not
it's
seeing.
it's descendants, not children. So 6, right? Let's say we have a parent, but even though 2 and 8 are not the direct children of the parent, 8 is like the grandson, like it's all the way down. You get me?
Okay.
Like they don't have to be direct children, but it just has to be under their ancestry. For example, 6, right? Let's say 8 was a 9, right? Let's flip those two numbers. 6 would still be the parent, will be the answer because 6 has a descendant of 2, and 8, even though 8 is not the direct children of 6, it's a descendant of 6, is the children of the of its children.
Is the
So it
children
has
of
to,
its children of its children.
yeah, it's the children of its children. So it's a grandparent. So the numbers P and Q have to be under the subtree, pretty much. Yeah or nay? Yeah or nay?
Is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants.
Yes. Descendants means that it's they're not direct children, but if you go to Excalidraw, right? Oh, we have it in Excalidraw. We can visualize it better here, right? So let me draw this out.
Oh.
Right? Let's say we have another number over here, x, right? And let's call this 9. Let's call this 7. Call this 9, right? So we're looking for 2 and 9 in this case, right? And even though 2 is here, right? But this is a 7, right? But 9 is over here. And since 2 and 9 are descendants of 6, even though they're not direct children, they're descendants of 6. And we're trying to find the lowest parent that's descendant of both. Even though this parent over here has 2 and 9 as descendants, 6 is the lowest parent that has 2 and 9 as descendants.
Okay, I'm catching it.
Yeah or nay?
No, that's a yay. That's a yay.
Yay? Okay.
Yay.
Yeah. So we're just trying to find the lowest node that has P and Q as
P and
descendants.
Q as descendants.
Yeah.
Okay.
Yes.
Okay.
Yes.
So now that we got that out of the way,
All good. How do we solve this though?
this song ain't it?
Huh?
This song ain't
This
it?
song game. Depth first search.
Okay.
Ufas.
I got it.
You got it? All right.
The
Tell me.
key is that it's a binary search tree. That's the key.
Yes. Yeah. Uh-huh.
We're given P and Q. We go find P. We go find Q. If they're on the same side.
Okay.
If they're on the same side, then the lowest descendant will be the parent of the highest depth node. Does that make sense?
Yes, I think so.
Let me draw this.
Okay, I was gonna draw it. Yeah.
So I'm gonna do this example right here.
Yep.
So if they're on the same if they're on the same side, let's say P and Q was 5 and 0. Okay? So this is P. This is Q. Okay? If they're on the same side, the lowest ancestor would be the highest depth. This would be 1, 2, 3. And then this would be 4. It would be the parent of the highest depth node. And that would be this.
Yeah.
Now, if they're on... Now, I haven't thought this one through. Maybe it's the same thing, but now if they're on different sides, so let's say this one and... Wait, if they're on different sides, then it would just
Is
be the... It would just be the initial node.
yeah. Uh-huh. Oh, did an alert
Yo,
come up?
appreciate... Yeah, we got a new subscriber. Appreciate for the new
Hey,
sub, man.
welcome,
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 welcome to
welcome,
the
welcome. Hey,
stream.
hey,
Hey, bro,
hey,
first time I
hey,
hear it. Hey,
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 hey.
hey, hey.
That's what we're talking
Woo,
about, man.
fuzz. Hey, welcome to the stream.
Welcome, 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 welcome.
All
So,
right, so
is that correct or no? Like, what do you think? What's the counter argument? Like, if
my
they're on
count,
different sides, the answer would be right here.
yeah, yes, yeah, yeah.
Okay. If they're on the same side, the answer would
Well,
be the highest depth parent.
yeah. Well, the thing is, this example, this one, where 0 and 5, they're also like different sides. One's to the left of 2, one is to the right of 2. So they're in two different sides too.
I like your way of thinking.
Yeah.
So in that case,
Yeah.
what
Yeah.
in that case wouldn't it always just be like let's say this one and this one. Oh, this one and this one. It would always
Yeah.
be the parent of the highest depth node.
Well, not quite. Because what if we have 3 and 7? It'd be still 6. But if
No,
the
but
highest
I'm saying
uh-huh.
if it's on the same side, the parent would be. Wait, no, it wouldn't be this because remember it said this could still count. This could still be in descendant, so it would be 0. It would be 2.
0, 2, yeah.
So if they're on the same side, then the highest depth is the parent. The highest
Since
depth
they're,
is the parent. Yeah,
if they're
the
in the same
highest depth node.
side. Yeah, if they're like on the same line, like on the same, like, yeah, if it's, yes, that makes sense. Yeah,
And
yeah.
then, like you mentioned, if they're on different sides, no matter what subtree, the parent is always gonna be the first node, the root of the subtree.
Yes, yeah,
If it's
yeah,
here, it's gonna
yeah.
be here. If it's here, it's gonna be here. If it's here, oh,
That's still gonna be 2.
still gonna be 2, yes. And if it's here, then it's gonna be the parent is gonna be the depth is
The
the
2.
highest or the lowest depth node.
Mm-hmm.
What am I missing?
No, I think you got it. Yeah, it's yeah. We're just trying to find the parent that has the two descendants. Yes, yes, and living they're in the same line. It's yeah, yeah. That makes sense.
Now the question is, do we want to code it?
I mean, we can try out the logic. We don't have to code it, but we can try out the logic and like draw it out and see, come up with something,
Okay,
right?
I'll let
Just
you
a
do
little
that.
bit, just a tad bit,
I'll let you do
you
that.
know? Okay.
Where you want to draw it out, or you're gonna write it out?
No, no, I'm gonna try it out because
Okay.
I'm coding for me right now. I'm cooked, bro.
Say that again. Coding for
Alright,
you.
I'm cooked right now.
Well,
Uh,
talking about cooked, I wanna cook.
oh, you haven't
Okay,
eaten,
I haven't eaten. I haven't
bro.
eaten or whatever.
What are you gonna make yourself? What's in the menu?
Well, yesterday I made migas again. You know what migas are, right?
Yeah, miguitas. Yeah, yeah, yeah.
Why do you call them mijitas? What's the difference?
Miguitas.
Miguitas. Why do you call them that?
Yeah, they're miguitas. That's the way you say it.
Migas.
No, not migas. Miguitas.
But are they the same thing?
Migas? No.
What's mijitas then?
Mijitas.
Migitas.
Miguitas. Miguitas. No, you say me.
I
Say it
say
again.
migas.
Migas.
Migas. Yes.
No, no, no. Miga. No, yeah, yeah, yeah. No, yes, 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 yes. You're saying it right. Just
Don't
with
make
a
me pull it
different.
out.
No, no, it's migas,
Look,
migas. Yes,
look,
yes, yes.
migas.
M. No, no,
And
no, no.
then
No.
what
Yeah,
are
yeah,
you
yeah.
saying?
Migas, migas. They're
But
migas.
yes, but what are you saying?
I'm saying migas.
No, you're saying
Miquitas.
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 Are those the
Oh,
same thing?
miguitas. Yeah, but just like it's like saying mijito. It's like mijo, mijito. Like I'm like making them smaller per se.
Okay. So
Miguitas is
how do you cook your migas?
uh
Or
miguita.
if
No,
you
I
do.
do. I cut the corn tortillas. Pa. Put oil
Yeah.
in the pan. Make it. Let it like get hot for a bit and go
And go
and
what?
hard and go. Psh, bro, put the corn tortillas. It has sizzles. Psh, and so
Yeah.
you go psh, in there.
Uh-huh.
Put some cheese, some mozzarella cheese in there. Sometimes some salsa. Make them what's it called? No molletes. They're called Oh, I forgot the word. It's a different type of migas. But yeah, I just
Chelita
put like
ch
chilaquiles. There you go,
chilaquiles.
chilaquiles. Yeah. If you put some salsa and some cheese, that's chilaquiles. But if I'm just doing migas, I'm doing some. I put it go the corn
Tortilla.
tortilla in there,
Uh-huh.
and then that's pretty much it. Put some salt in
Wait,
there.
no egg?
Oh yeah, yeah. I was going there. I was going there. I
Okay, my
put
bad,
some
my bad, my
egg in
bad.
there. I put some egg in there. Boom, boom, boom,
Uh-huh.
and you got your migas.
Oh, do you put tomato sauce?
Not quite. Nah.
So you just do tortilla, egg,
Tomato, like
seasonings,
what type of tomato sauce?
tomato sauce,
Like this,
like
the
this,
thick one? Let me see.
like this.
Oh no, 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 no,
It's
no,
not
no.
thick though. It's like pretty runny. What do
I
you
don't put tomatoes. I
mean?
don't put tomato sauce, but I put some salsa.
So you put salsa on it.
Yeah.
Okay. All right, my bad.
All good. All good.
Continue.
Yeah, I put some salsa. Only if my mom makes it, cause I don't know how to make salsa. So she's the one. She's the expert. Oh, bro, you got me hungry, bro.
Oh
Oh,
yeah, that's what I'm trying to make.
oh, you gonna get
But
miguitas again?
I'm over here stuck doing this thing.
We can call it a day. We can call it a day here.
Oh, now I want to figure it out. Like, is that the way to do it or no?
No, it is. It is. I think it is the way to do it. Where where we just have to traverse each little thing, and we're gonna have variables for like P and Q. And if we hit P, you set to true. If you say Q, you set to true. And then
No,
okay, yeah,
no.
no, no,
We're gonna
okay,
do
no, no.
death first. We're gonna do uh uh what's it
Breath,
called? Breath first search.
okay.
Since we want to get what's wrong with this, man? Since we want to get the layer, But the question is, how do we figure out if it's split? If it's over here and it's over here. That's the question.
Well, not just that. How do we find the parent? Because it's gonna be an array. Welcome, Plat the Man. Hello, welcome to the
Hello, what's
stream.
up? Good seeing you, man. You know you make me angry, right? You know that?
Bro, what do you mean? What do you mean?
So then, how do? Okay.
We can figure it out next time. We can figure it out next time.
I think you're
Ni
right.
hao.
Though. I think you're right. Ni hao, how you doing, man?
Ni hao, how you doing, brother?
Doing good. That's good.
Yeah.
All right.
That's good, brother.
I need to go make some food, bro.
Yeah. Glad the Man. I'm sorry, brother, but you catch us the last few minutes of the stream. You know, but I'm glad you're here. I'm glad you're doing okay. I'm glad you came over here and support us. Even if it was for a little bit, you know. Apologies, Glad the Man. You're still the man. But yeah, I'm ready to call it here. You know, you're hungry. You're tired.
Man.
I'm tired too.
Yet. Well, maybe I am tired.
Yeah.
But
no, I'm tired. My head hurts. I'm like, oh, bro, take a good nap.
Platt wants to talk to us in Discord.
Client wants to talk to. Okay.
Voice channel.
Oh, BC.
Well,
Ooh, for the live stream.
Well, for the live stream.
Yeah, but hey, I'm down to do after the stream.
Like right now, we could just chat for a little bit. I'm down.
I'm down for that too. Yeah.
I might be making some food though, but
yeah, all good, brother. All good.
I'll be there listening.
I'm gonna be folding some laundry that I have to fold, but I'll be there. I got you.
All right, Clat. Well, if you're down, we'll be there. We'll be in one of the channels.
Yep.
Right, you do the outro, man. I'm on a go.
All right, guys. Thank you for coming in. Thank you for tuning in. Thank you for everything. Have a great day, great morning, great afternoon, great evening, great night, whatever time zone you guys are living in. Just have a great day. Thank you guys for coming in. Bye bye.
See y'all next week. We'll see y'all next week.
See y'all next week.
Wait. I might have to
reschedule.
Wednesday. We might have to do it at a different time because I think I have a doctor's appointment. During that time specifically. So we'll update y'all. But it has to be Wednesday. Sure. We gotta figure it out. We'll figure it out.
Yeah, we got you.
All right.
Alrighty. All right. Thank you guys. Bye bye.